All right, let's get into it. Today, we're going to dig into the roots of one of the biggest ideas of our time, data mining. I mean, you hear the term data mining thrown around all the time, right? It almost sounds like some kind of magic. But, it's not. It's really this powerful idea that was built piece by piece from a bunch of other revolutionary concepts. So, a good way to think about it is like a massive tree. And to really get what's going on, you can't just stare at the leaves and branches. Nope. We've got to go underground, get our hands dirty, and really examine the roots. Okay, so here's our map for today. We're going to trace 4, let's call them foundational roots. Everything from databases to business intelligence. These are the things that gave data mining all its power. And then at the end, we'll take a peek at what might be the next big branch. All right, first up, let's start with the absolute bedrock, the soil everything else grows from, the database. This is really where we as humans first figured out how to bring some order to the chaos of information. See, a database isn't just a random pile of information, not at all. It's an organized collection. It has this specific structure, a schema, which you can think of as its blueprint. That blueprint lays out exactly what the data is and, crucially, how all the different pieces connect. And this right here, this is a perfect illustration of that structure. It's called an entity relationship diagram, or ER diagram, and it shows us those connections visually. You see how employee is linked to their job? It's that structure that lets us start asking really smart, meaningful questions. So, how do we ask those questions? Well, we use a language, usually something like SQL. And a classic SQL query, it's like a laser beam. You ask it a very specific question, like show me all the employees who make more than $100,000, and bam, it gives you exactly that list. Super precise, right? But also kind of limited. And this is the absolute key difference, the big takeaway. A database query finds what you already know you're looking for. The answer is just a slice of the data you already have. But data mining, that's the total opposite. It's about discovering the questions you didn't even know you should be asking. It finds something brand new, a hidden pattern, a surprising rule, an insight that was buried deep in the data. Okay, that's route number 1. Now let's move on because, let's be honest, the real world isn't nearly as clean and tidy as a database, is it? It's messy, it's uncertain, and that's where our second route, fuzzy logic, enters the picture. So traditional logic, the kind that databases love, it uses what are called crisp sets. It's all black and white. You're either short, or you're medium, or you're tall. The lines are drawn in the sand, they're absolute. No kinda tall allowed. But that's not how reality works, right? A fuzzy set, on the other hand, is designed to handle that messiness. It lets categories overlap, so someone isn't just tall or medium, they can be kind of tall or on the taller side. It brings in these degrees of truth, which, let's face it, is a lot closer to how we actually talk and think about the world. And why does this matter? Well, it's absolutely crucial for making complex decisions. Just look at this example with loan approvals. The crisp model on the left, it's a hard yes or no. That's it. But the fuzzy model on the right, it creates that gray area, that maybe zone. And that is so important for data mining because almost all the really interesting problems, whether you're talking about customer behavior or medical stuff, they all live in that gray area. Okay, on to route number 3. This one comes from a classic problem. How do you find a needle in a haystack? But in this case, the haystack is all the text in the world. This is the domain of information retrieval. And believe me, it's the science that powers literally every single search engine you've ever used. So think about it. Anytime you search for something, there are really only 4 things that can happen. Best case, you get back stuff that's relevant and you don't get back stuff that's irrelevant. But you can also mess up in 2 ways. You can miss something really important, or you can get a ton of junk that you didn't want. This whole thing forces a really tricky trade-off, and we measure it with 2 big ideas, precision and recall. Precision is basically asking, of the stuff I got back, is it any good? And recall asks, did I manage to find all the good stuff that's out there? And here's the kicker. Trying to improve one of them usually makes the other one worse. It's this constant balancing act, and it is right at the heart of what data mining is all about. So to get better at that balancing act, the systems had to get way smarter. And one way they did that was by using these concept hierarchies you see here. The system learns that, hey, a tiger is a kind of cat, which is a kind of feline. So now, when you search for cat, it's smart enough to know you might also be interested in stuff about tigers. This idea, understanding how concepts are related is a direct ancestor to so many of the data mining techniques we use today. All right, that brings us to our fourth and final root. This is where the rubber really meets the road, where data starts to mean dollars and cents. We're talking about business intelligence. And the whole point of BI is to take all this data and organize it in a way that helps actual people make smarter decisions. The big idea in this world is something called dimensional modeling. It's pretty cool. Instead of just looking at a giant flat list of sales transactions, you organize the data around the questions a business actually cares about. Things like, what did we sell? Where did we sell it? And when did we sell it? This model lets you slice and dice the data along all those dimensions at the same time. And one of the most popular ways to do this is with what's called a star schema. It's easy to picture. Right in the middle, you have a fact table. That's just the numbers, the cold, hard data like sales quantity and price. Then, shooting out from the center like the points of a star, you have dimension tables. These give you all the context, the who, what, where, when. So you'll have product info, store locations, dates, all that good stuff. And what's great is that this structure makes asking really complex business questions surprisingly fast and easy. Okay, so we've traced all 4 roots. Now let's take a step back and look at the amazing tree that's grown from them. The big takeaway here is that data mining wasn't some single magical invention. It was a convergence of all these great ideas. Databases gave us the structure, the fertile soil. Fuzzy logic gave us a way to handle the messiness of the real world. Information retrieval taught us how to find the truly relevant stuff. And finally, business intelligence gave it all a purpose, turning all that raw data into decisions that matter. You know, every single one of these roots was a massive breakthrough on its own. But when they came together, they grew something way, way more powerful. So that leaves us with a final question to chew on. As data becomes, well, the new soil of our entire world, what new roots do you think are taking hold right now? What's getting ready to grow the next incredible branch of data mining?